Thank you, Will, and thank you all for staying to the bitter, bitter end of an AI conference. I know we all have family to go and see on a Sunday afternoon, and some people have the UK train network to battle with. So we're going to try and get this wrapped up as quickly as possible, but our lovely hackathon teams have been working on this for the past 28 hours, so it's only fair that they get a chance to show you what they've all been working on. So just to quickly give a rundown of the rules, we kicked off at about 9 AM on Saturday and wrapped up about midday today. So 28 hours roughly to build using the latest generative AI tools. We had 5 teams using sort of generative AI to create a solution for a problem so they could work on almost anything that they wanted, as long as all the work that they produced in this time was original, they hadn't started work on it before. And I don't think many people slept, or at least got a solid night's sleep. Part of this was also, we had some amazing help from our sponsors. So we had Quine, Helm, Foundry, and Humanloop all helping to sponsor. And we also had data provided by the British Medical Journal for teams to work with. In terms of the Humanloop tooling, it's an amazing tool that has helped a lot of these teams to be able to produce what they were to produce today. And they've been kind enough to sort of give a demo to the audience to show you what their platform is capable of. So for that, I'd like to introduce Conor, your head of growth.
Hi, guys. I'm just going to do a quick walkthrough of what we do at Humanloop. And then I can just do a short demo as to how we help teams at the hackathon this weekend. So has anyone here heard of Humanloop before? Is anyone familiar with the company? Okay, few from the hackathon, okay, fair enough. Yeah, so what we do is we help companies build reliable applications on top of large language models. Mainly, we provide a collaborative environment where teams can test models, develop prompts, and then measure and test performance over time. We've been used by over 10,000 developers, and we're deployed in over 2,000 LLM projects for companies like Amex, Duolingo, Gusto, and FMG. So, big picture, LLMs are everywhere at the moment. These are just a few examples of how LLMs have been used to create value in various parts of the economy just this year alone. And we can see that this trend is obviously real. AI can create value, and it doesn't discriminate in terms of what sector it does create value in. It's all parts of every industry. But there are universal challenges to building apps with LLMs. Namely, they hallucinate. Prompt engineering is still a challenge. Evaluation can be very subjective, and testing is difficult. And then there is another component for internal companies, which is that cross-functional collaboration is often required to get domain expertise into the problem that you're trying to resolve. So if you look at these 3 problems individually, the first one with prompt engineering is most companies don't actually have a prompt management system in place. Usually what we see at companies of all sizes is that they're using previous tools such as Jupyter Notebook, Visual Studio Code, Excel, and in some of the worst cases, Google Docs, to actually manage their prompt engineering. So this is actually a big challenge, because what happens is when you're managing your prompts in these sort of tools in isolation, you can't actually check the history of their performance, so how they're actually changing over time and how you're performing them. You can't track how each prompt is performing in production. You can't tie that data back, and you don't accumulate any learnings. So what really happens here is when you develop the prompt, you ship it, and then it's fixed, and you don't know what's going on, and you're in a bit of a black box. When it comes to evaluation, there's multiple problems. The first one is there is no systematic process around evaluating LLMs. It's still something that the industry is very much tackling. Techniques vary per use case, so you could be evaluating an LLM that's writing JSON, for instance, and you could objectively value that quite easily, but then you could evaluate an LLM that's giving emotional advice. and that's much more subjective. So there's a huge variation in terms of what they're doing. And then it also depends what part of your model you're actually evaluating, right? So you could have a retrievals part in your chain, or you could have sort of just like a pure prompt. And effectively, you need to evaluate each step. So there's a whole framework that needs to exist around actually evaluating your models in production. And existing frameworks are often manual. They're often just people looking at model performance and just ticking it off, and it's time-consuming and they're subjective. Without a proper evaluation framework, it's impossible to actually measure what you're doing and how it's performing. And then you're also assuming that things are not possible, which could be done if you had a proper evaluation framework for your LLMs. And then finally, collaboration is another key issue that we help resolve, which is prompts going into production a lot of the time don't have the input from the domain expertise which are required. So a good example of this is, say you're building a sales tool and you want to write sales copy, okay? You can get your engineers to build this sales tool, right? But what you really want to get is your best sales development representatives to assess the copy and really get the best performing sales copy out of the model effectively, right? So you want that domain expertise. That domain expertise should always be in the loop. It doesn't just exist at the beginning and then you deploy it. It should always, it's an integral part of the framework when you're deploying LLM applications. Without proper collaboration, you get underperformance from the model and you get undifferentiated output relative to your competition. So how can we help? Well, what we do is we sit in between your LLM and your end application. And we essentially provide tooling to help resolve all of these problems. We're model agnostic, so for instance, you can get your OpenAI models, Anthropic, Cohere models. We also do some open source models. You can bring these into our platform where we provide all the software management tooling for you to customize it, and then we also leave the front-end application very much in code so that you can deploy into any kind of application and you're not limited by any kind of frameworks that we create. So in our prompt engineering tool, it's AI native prompt management software, which I will show you in a minute. But effectively what this is, you come in and you start at the prompt, and prompting is at the core of the journey. From once you write the prompt, you can deploy into your application, and everything is tied back to that one prompt that you have in deployment. You have your teams collaborating on it, you have evaluations attached to it, you have data being logged in real time, all to do with that one prompt. We provide a flexible and intuitive workflow for actually evaluating model performance, where you can do so in code by actually writing functions, or you can actually get another LLM to actually evaluate how your model is performing in real time. You can do this through regression testing, which is where you actually have a batch of inputs and you evaluate them rapidly while you're making changes to your prompt, or you can do it in actual real time where you're evaluating every generation your model is making in production. And then finally, when it comes to collaboration, we actually provide a collaborative environment which makes it simple for technical and non-technical team members to get involved and work together on their LLM applications so that they can bring that level of domain expertise. And really what this allows them to do is to try out every model that's available to them, really rigorously develop prompts that are really good for production, and then monitor them over time with data. When you build an application with Humanloop, what generally happens is you get to build your applications a lot faster, because we have a first principles tech stack for building these applications, and they're production grade. You generally reduce costs because you're actually saving on engineer hours that go into producing these apps, as well as you're able to optimize for latency and cost on tokens. And then you can actually enhance the reliability of your applications through guardrails, minimizing hallucinations, and continuously measuring and evaluating output. So that's Humanloop in a nutshell. And what I'll just really quickly do, if we have a couple of minutes, is I'll just show you how this actually works. So here, we're just at the Humanloop homepage. What I'll do then is I'll sign in. And really what happens is anyone who comes onto Humanloop at any team just creates a project. And what a project does is it effectively is just a prompt or an LLM feature that you're going to deploy. Right, so when you come in here, you have like a dashboard. This one's obviously empty at the minute. What I'm going to do is create a prompt, and I say, you're a helpful assistant, like answer queries, for instance. Once I have this prompt saved, I can then just check like what model I want to deploy it from. So it could be GPT-4, GPT-4 32K, but we also have like Llama 2 here. We have Claude, et cetera, et cetera. And then in GPT-4, then you have a playground experience where you can actually test various models, right? So what I just do then is just you can just say hello, like how are you? It's just a very basic standard format for actually generating getting models generations from the model. All right, cool. So then once you actually have a model and working, now obviously this is just a very basic standard use case, but what you'd want to do is you'd want to deploy this into an application. You save your model config. Let's just change the name. And then once this is saved, you have it deployed into an application. So it's saved, I hit deploy. You can imagine this is going into your app. And once it's deployed, then you have a dashboard here where you're actually going to measure the performance coming in from the prompt. And you can then work on it iteratively over time. So that's just how you get started. I'll show you this actually looks like in production. So here we have, this is from the hackathon, where you have, you're a co-pilot for healthcare. Your job is to answer patient queries. And if a patient asks you what their options are, receiving diagnosis, la-da-da. So what we've done here is we have our prompt template, but we've also brought in function calling. For those who are not familiar with function calling, it's a way for the models to decide whether they're going to make an API call based on a user's input. We actually support sort of function calling natively in the platform. So here I've already integrated Wolfram Alpha API and another API to actually get medical journals. So we're actually, from the playground, we're actually able to give the model powers to go beyond its training data and actually retrieve from other data sources, right? So in production, that's what this would look something like this. If I say, get me 3 papers related to COVID. What's going to happen is that prompt that I have deployed to this application is going to receive this query. It's going to decide then whether it needs to use a function calling method, which it did, and then it's going to use that data to respond to me. So I can open this here, and I'm sure it's a paper on COVID-19, great. So what's actually happening there inside Humanloop is if I just look at my dashboard, I can see here's my prompt in production. There's some metrics here as to sort of the data that's coming in and the feedback that I'm getting. At the moment, I'm not giving the model any feedback, so that would be quiet. But I can view the data from that prompt that's in production. And when you look here, you can see the latest query that's come in from the app is, get me 3 papers related to COVID-19. This is, I'm not seeing this on my screen. Okay, there we go. That doesn't happen in the app, that was. Anyway, get me 3 papers related to COVID-19. You can see the model then decided to do its tool call. You can actually see the data then coming in from the public medical journal and then your model responding, right? Now, if you're using this in production, what's actually happening is you can assess every single data point that's coming through your model. And then you can actually evaluate it, you can correct it, you can capture, internally, you can say whether it's a good or bad generation, or you can use a bunch of different tools to actually evaluate it. And then effectively what you can do is you can collect all that data and use it over time to then further improve the model and enhance its performance. So that's in a nutshell how they would have used Humanloop at the hackathon. But then beyond that, we also allow, which I can't demo today, which is we also support experimentation, which is experimenting A/B testing different prompts. Fine-tuning, which is when you collect all your data points and then actually use them then to fine-tune a model, which you can then deploy. And then we also provide a suite of evaluations as well. So this is evaluating your model in real time or in batch testing. So yeah, that's Humanloop in a nutshell. And yeah, I'm going to hand it back over to Harvey now to close out the hackathon winners. Thank you.
Yeah, so we thought we'd give each team a chance to just quickly demo what it was they were able to build in the last sort of 28 hours. Just for the teams, when you come up, it should be ready to go. Oh yeah, I should also talk about the judges as well, that judge this. So each sponsor was kind enough to provide a judge for the hackathon. Conor was there the whole weekend showing everyone how to use the Humanloop platform and troubleshooting. But we also had Tahseen Omar, who's the COO at Helm, and Alistair Garfoot, who's Director of Intelligence Architecture at Foundry, and Dr. Rodrigo Mendoza, who you might have heard just talk earlier, and he's the founder and CEO of Quine. So yeah, as the teams, when you come up, try and keep it as short as possible. Everyone wants to get home to their families and just talk through what your tool does and what you managed to build in about 2 minutes, please. So up first is Bahila, if they are here. I saw them earlier. No? They left? Okay. They built an NLP tool for basically extracting news from the web, and were able to make it sort of an importable package for NLP practitioners. Up next was MedExplain. So it's just the video.
Okay, yeah. Hello, everybody. It's a bit weird. Let's just click play on this. And essentially, we have a post-diagnosis tool. So if you're a patient or a doctor, and you can then interact with this chatbot to understand more about whatever you've been diagnosed with. For example, I've been diagnosed with iron deficiency. I can then communicate with our chatbot, and it then gives us some nice NHS links for us to actually communicate with and learn more from. And we can show that that actually does work. And further on from that, we can ask it for a bit more information. So if we're a bit like nifty and we want to ask a bit more, like we want to see like modern research, we can say like, I'd like to know more about this specific treatment, and this will then query the similar model that was used in the Humanloop talk just now. And essentially it will then show us papers related to whatever we feel like is up. And conversely to that, we can do the similar sort of thing, but from a doctor's perspective, where you can use like proprietary, like a data set of just PDFs for, oh, I started again, my bad. Yeah, so let's just pause there. So that's then, from the doctor's perspective, they can then have their own data set of small PDFs and that kind of thing, which we can then parse and show that in a nice format just for the doctor, so that they might have their own notes and that kind of thing. Anyway, yeah.
Just to summarize, we wanted to create a tool that's sort of in between doctors and patients, because increasingly we want more patient governance, and even clinicians that we spoke to agreed that patients now want to be involved in the decision making, whether it's something as simple as should I give antibiotics or not for this infection. So that's why we thought this is more of an informational tool to sort of increase that collaboration, and we would love to build on future features in this space. Thank you.
Maps AI.
Yeah. Hey everyone, we're fixing Google Maps. So no longer you'll be searching by keywords, but you'll be searching by memories, thoughts, and experiences. Here's a quick demo to show you how that works. I'm a runner. I like to run, but when I'm running, I see things that I can't remember what their names are or what they actually are. Suppose I'm in the Chiltern Hills and I'm sort of running through a field on a common running route, and I see a manor house. I'll ask Maps AI to sort of give me what these manor houses might be. I might not have a specific one in my mind, but if I tell it my journey and my thoughts and my experiences, it will tell me on my maps where I was. Say that again? Check. I don't know what that means. Oh no, it's not the Prime Minister's country house. It's a different one. It's when you see it. It's not Chinese Manor's house. It's not Hampton House. It was that one. Waddesdon Manor. But that's how it works. And yeah.
Next up, we had MLLM.
Okay, so our team name stands for like multiple large language models together. So our idea was kind of that we came more from a user perspective, saying that maybe it will change how we will search for information online, and that we will use like ChatGPT and these kind of applications more often. And we wanted to ensure that like the information we get is like more diverse from more backgrounds. So we kind of implemented a structure where we would put like different LLMs together, and then they would kind of combine their answers to the questions and give out this question with like some meta statistics about like how diverse were the outputs and like how was the text overall, were there different perspectives, or would they only like look at one of the aspects. And we really wanted to have an interface, you can see it here, that you can really use. So you can type in a question. Yes, and you can give it some metrics of whether you want to be it more objective answer or like more opinionated. And you can type in your question basically, and you get out the answer in a second. So, is AI a danger to humanity? And then you kind of get the answer first, because we feel like if people would want to use this tool, they would want to get an answer. And then clicking on it, you could get kind of like some information, like were there different ones, like different information put in the different LLMs, or you can see all of the text, so it would really contribute to like seeing what different LLMs would answer to this question. It's a bit more complex what we did in detail, but I think that's the main idea. Yes, thank you.
And Haggle? Edwin, is there sound? No.
Even just out of the laptop that we can mic up? Yeah, that'll be fine. Yeah. And we have to use the link.
Okay, hello everyone.
Yeah, I was just saying that. Yeah.
Hi, everyone. So social anxiety is one of the most common disorders in the world. At Haggle, our mission is to help people overcome social anxiety and practice their communication skills in challenging situations. So we're going to show you now a quick demo of how the product works.
Everyone, we are Haggle. We are the software platform where you can practice your communication skills and overcome social anxiety in difficult scenarios. And so our first target market for our product is software engineers. And we have a few different scenarios that they might be in. So firstly, it might be a job interview with a panel. Another might be a company strategy meeting, or maybe they're giving negative feedback to a colleague. And you can see that when you click these different calls to action, you can actually populate a prompt, and that can that then determines how the AI sets up the scenario. So I'm going to go ahead and click panel job interview, and I'm just going to change some information here. I'm going to say it's actually at Google, and I'm going to say, I'm actually going to leave my name out, but it's in my CV, so I'm going to upload my CV. Click upload, and then we press begin.
Hi, Henry, welcome to Google. Let's go around the table and introduce ourselves. I'm Janet, a VP of Engineering within the Google Cloud Platform team. Could you introduce yourself, Henry?
Yeah, sure. Hi, I'm Henry. I'm a data scientist. I work at a legal tech company. I've been a data scientist for about 4 years, and before that I did a PhD in physics. And yeah, I'm really enjoying hackathons and cooking.
Nice to meet you, Henry. It seems like you have a diverse background in both data science and physics. I'm curious, how did you transition from being a physics student to a data scientist? Can you tell us more about your journey?
Yeah, so thanks, Brian. So I transitioned from physics to data science because I realized I was never going to be a good enough physicist. So I saw what else was out there, and I realized that actually you use quite a lot of maths and data science, and some of it's quite similar to physics. So I just jumped at the chance.
Interesting perspective, Henry. It's great that you recognized your strengths and found a new path in data science. In your resume, you mentioned that you built a virtual assistant for commercial property lawyers called Orbital Copilot. Can you share more details about that project and what impact it had on the users?
Sure. So the users are commercial property lawyers, and it speeds up their workflow. I don't really have much else to say about it.
I see. It would be helpful to understand how exactly the virtual assistant speeds up the workflow for commercial property lawyers. Can you provide more specific examples or details about the features and capabilities of Orbital Copilot?
Okay, cool. So you can see there that I've had a chat, and I've got Janet, the VP of Engineering, Brian, the product manager, and yeah, I've had this kind of natural back and forth chat, and we're using generative pre-trained transformers in the background, and various text-to-speech voice APIs and things. And you can see here this little call to action of generate feedback, and I'm going to click go there. And this is running an analysis in the background to give me some feedback on how well I did in that interview. And this feedback system will be across all of our different products and scenarios. So that is everything.
I'm just going to end it there, because that's the end of the demo. Thank you very much.
Okay, so I think before we move on to the winners, I think if we can just have one more round of applause for everyone. I think it's incredibly... It's incredibly impressive that a lot of these people that were participating in the hackathon, they hadn't met each other before. They formed this team for the first time on Saturday morning, and they've been able to build all of this in 28 hours, which I think I wouldn't be able to do it, so I find it hugely impressive, and I think the quality is testament to just how brilliant they all have been. So we sort of had two tracks. We decided to go with an overall winner and a winner of social good. The winners will receive £500 in cash, so Humanloop credits, and T-shirts where they can design them themselves, and the design is generated by AI from a project of my own. It's a bit lame, but it's cool in these circles. So yeah, moving on to the winner of the social good prize. We chose this because we think there's a real use case. The judges chose it because I think there's a real use case for this and assessing the problem which it set out to solve. So yeah, going on to it, the winner of the social good, we went with MLLM. So if you'd like to come up and... I have some certificates if you'd like to come up. And then next up for the overall winner, I think this winner was chosen for the overall sort of commercial viability of this solution. There's a real problem that it sets out to solve. The user interface was smart and clever, and there's definitely room for sort of scaling this into different domains and future use cases, and it sort of meshes well with potential future technologies. So the winner overall that was chosen was Haggle. I did also take some notes during the judges' discussions because I wanted to communicate how close the decision was and sort of what we were thinking. And they're not on my phone. They haven't synced with my phone yet, so they're on my laptop. But I think for the NLP tool, we were really impressed with sort of how it was able to explain its sources. So that was what we really liked about that. With Maps AI, we really thought that it was a problem that people might have. It was just maybe not quite, we don't know how you get sort of tractionize paying users. But we really liked the sort of general solution and how you went about solving it, particularly with the integration with Google Maps. And it's been a long day, so I'm really sorry if I am forgetting someone. I know I'm forgetting someone. It's really bad. Now I'm looking around there. If I just go. Oh, MedExplain sorry, I can't believe I've forgotten you after everyone, because you made amazing use of the available tools that you had available to you. Using the British Medical Journal data was, we really liked that, and also the making use of the Humanloop we were really impressed with, and your overall sort of making use of tools was great. So I hope that sort of wraps up this closing ceremony. I hope everyone's had an amazing time here. A massive thanks for Cassidy and the rest of the volunteering team and exec team for bringing us all here, and I hope everyone has a safe journey home.
All right, thanks, Harvey. And it's so incredible to see the projects that have come out of the hackathon, and I'm absolutely blown away. I also would not be able to do any of that, and really, really cool to see all those projects and the demos. I'm exhausted. I'm sure everybody here is exhausted. It's been a long weekend. I hope that you all had an incredible time, either in the panels, speaking in a session, attending, participating in the hackathon. Huge thank you to Harvey for directing the hackathon, and to our exec team, our volunteers, our sponsors, and everyone that has been here throughout the weekend now until the very end to bring this to life and make it possible. That's it. I want to wrap it up. Hope that you all have a great evening and week ahead. And thanks so much, everyone, for coming out this weekend and helping to support us.